Hello everyone, myself Shilpa from St.Georgia Girls School. Today's our topic is metallurgy. Occurrence of metal. Metals are occurred either in the form of free state or in the form of combined state. The low reactive metals such as silver, gold, platinum, they are found to be occurred in the free state because they are less reactive. They cannot react with other elements easily. While the highly reactive metals such as potassium, sodium, calcium, magnesium, etc., they are found to be occurred in the combined form because they are highly reactive, so they can react with other elements and form compounds. So they are present as a combined state. The natural substance which bear the metals naturally present on the earth crust, these are called mineral. The mineral, a special type of mineral from which we can extract the metal profitably, means the amount of metal on that mineral, in that mineral is more and the impurities present in that mineral is very less, so that we get metals profitably. This special type of mineral, we call it as a ore. The impurities present in the ore are called as gangue, while the impurities that added to be in a furnace to remove the gangue are called as flux. These flux is combined together with the gangue and form slag. Metallurgy. The process of extracting metal from the ore and refining them for the use is known as metallurgy. The basic steps are: first step is crushing and grinding the ore. The ore should be crushed or grind by the physical different means, such as by using machines or rollers, to make it in a powdered form so that gangues can be easily removed from it. Next step is concentration of ore. Concentration of ore means to remove the gangue particles. This can be done by the different process which we will discuss in the next. Third step is extracting of metal. That is in two steps. First, the metal ore is converted into oxide ore, and then oxide ore is reduced to metal, and the last step is refining of metal. The first method of concentration of ore is hydraulic washing, or it is also been known as gravity separation or levitation. In this, the powdered ore, the ore which is crushed or grind, that powdered ore has to be washed by the stream of water, heavy stream of water. The ore which is having heavier density is get settled down at the bottom of the tank and get separated out by the outlet, while the impurities present in it is having lighter density, less density, get floats on the surface and removed from the tank through an upper outlet. The second method for the concentration of ore is magnetic separation. This works on the principle of having different magnetic property of ore and the impurities present in it. As for example, the ore of tin, which is called as tin stone, contains wolfram as an impurity which is magnetic in nature. To remove this impurity, the ore is finely powdered to make the magnetic and non-magnetic particles are differently separated out. The powdered tin stone is spread on a belt moving over electromagnetic rollers, and the wolfram, which is the impurity present in that, is being magnetic in nature, get attracted toward this wheel, and collected in a pot near the magnet, while thin stone falls away from the magnet. The next method for the concentration of ore is froth flotation. It is mainly done for the sulfide ore. The finally powdered ore is mixed with water and small amount of oil in a tank. Air is pressurized at a very high pressure into this mixture. The froth or scum is produced at the surface. Here, ore particle is get wet by the oil particle, while the impurities are wet by water and floated and get sink at the bottom of the tank, while the ore particle wet with or mix with the oil and form scum, that is froth, and get collected at the top of the surface of the tank. An acid is added to break up the froth. The concentrated ore is then further filtered and dried. The last method for concentration of ore is leaching, or we also called it as chemical separation. This works on the principle that the ore and impurities is having different solubility towards a particular solvent. In this process, the powdered ore has to be treated with a suitable solvent. Sodium hydroxide is one of the very common solvent and a strong solvent. Let's take an example. The bauxite ore of aluminium is having iron oxide and silicon dioxide as impurities. This ore is powdered and then treated with a solution of sodium hydroxide. After treating with sodium hydroxide, this aluminum oxide and silicon dioxide get dissolved, forming sodium aluminate and sodium silicate. The impurities which are not dissolved in it, they left behind. The impurities are filtered off. The filtrate that we get containing sodium aluminate and sodium silicate is treated with the aluminum hydroxide for several hours. Sodium aluminate undergoes hydrolysis and form a precipitate of aluminum hydroxide, while sodium silicate remains in the solution in the dissolved form. This precipitate of aluminum hydroxide, this precipitate is then further filtered, washed, and we get pure alumina, that is Al2O3. The ore is first crushed into powdered form, then after it has concentrated. It is concentrated by different means. Then this concentrated ore, we extract metals from this concentrated ore. Here is a chart given. Metals are generally categorized as a three categories: low reactive metal, middle reactive metal, and high reactive metal. Low reactive metal such as gold, platinum, silver, they are found to be in a free state, but few of them like copper, silver, few of them are found to be in the form of sulfide ore. This sulfide ore has to be roast or undergo the process of roasting to convert into metal oxide, while middle reactive metal is like zinc, iron, nickel, copper, tin. These are found either in the form of carbonate ore or sulfide ore. To convert carbonate ore into metal oxide, calcination process is done, while to convert sulfide ore into metal oxide, roasting process has to be done. Let's come to the highly reactive metal. Highly reactive metal which are placed at the top of the reactivity series, such as potassium, sodium, calcium, magnesium. These are very highly reactive. They react with oxygen immediately and form oxide itself. It is mainly found as a oxido or halide, which has to be reduced by the process of electrolysis. Roasting is a process in which metal ore is heated in the presence of excess oxygen or air. This is done for the sulfide ore, while calcination is done for the carbonate ore. In this, the metal ore is treated or heated at a very high temperature in the absence of oxygen or air. These both processes are applied to convert this metal ore into metal oxide. Now, our second step of extraction of metal is to convert or to reduce this metal oxide into metals. The reduction of metal oxide into metals can be done by the two processes. First is by using reducing agent such as carbon, which is also been called as coke, or carbon monoxide, hydrogen, ammonia. In this, metal ore is react with carbon or this reducing agent to get reduced into metal. The process in which any metal ore, metal oxide, is treated with the coke, this process we call it as smelting. Here is one example given. Zinc oxide is always reduced by using coke only, or you can say by the process of smelting. Now second process is by using aluminium. The middle reactive metal or the metals which placed below the aluminium in the reactivity series such as zinc, iron, lead, copper, they can be reduced by applying or by treated with the aluminium powder. This is a type of displacement reaction. Here, aluminium is more reactive than these elements, and that can displace these elements from their compound, from their oxide. This process in which metal oxide is react with the aluminium powder to get reduced to the metal, this process we call it as thermite process. This reaction is highly exothermic. It is done for the metals such as manganese, chromium, iron, etc. The mixture of this metal oxide, or such as if we take example of iron oxide, or the mixture of this iron oxide with aluminium powder is called thermite. This thermite is also been used for the joining purpose, such as the thermite, that is the mixture of iron oxide and aluminium powder, is used to trickle down to weld two iron objects together. Cracked machine parts, railway tracks, etc. are joined by this method.